One of the core concepts in the HTTP specification is the concept of content negotiation. This is where a client asks for a resource, like a list of videos or a stock quote, and when it requests the resource, it also includes an HTTP header, the accept header, to tell the server the representation it would prefer to see. There is also an accept language header for the client to tell the server the language they would prefer, like French or Swedish or English. And there are headers to specify the desired encoding and character set, but we're going to focus on the accept header for just now. The accept header that you see on the screen in the arrow is an accept header saying, I would like a PNG image. And the reason this is important is because a server might be holding a particular resource, like the stock price for Microsoft, but that single resource can have multiple different representations. We could take that stock price resource and render it in an HTML view, or we could render the stock price in XML, or in JavaScript object notation, or maybe as an image. The idea of having a single resource with multiple different representations, that's a central theme in the web, and it's one of the reasons the web is so interoperable, because we can, if we try hard enough, always give the client the representation they want to see, the representation that they know how to work with. The Web API will take care of content negotiation for us. Essentially, there are different formatters that are plugged into the Web API runtime, and each formatter knows how to handle a specific media type. Media type is the fancy term we use for how to represent a resource. Do you want a media type of JSON, or XML, or HTML, or JPEG image? If you want more details on content negotiation and HTTP, see my HTTP course here on pluralsight.com. For now, let's see how content negotiation works in our project. With the application running in debug mode and curl opened up, let's go back to where we were just requesting the get method for all videos. And with the breakpoint set there, I'm going to go into debug windows and open up the immediate window, which if you've never used this before, it's a wonderful little interactive environment where you can play around with things. And I want to look at the global configuration object in ASP.NET MVC, which exposes a static property global configuration.configuration. And inside of here, you can see that there are 4 formatters that are registered in ASP.NET MVC by default. This is a collection that you can add in your own formatters. You can remove the default formatters. But if we look at what formatters are, we can see that formatters are things that take an object that I return from a Web API method, like getAllVideos. This is just a string array. It takes one of these objects and builds a representation out of it in a specific media type. For instance, there's the JSON media type formatter and the XML media type formatter, and then a couple formatters to deal with essentially form data. And the default formatter that's going to be used if the Web API doesn't know what to do with a particular request is going to be the first formatter here, which is the JSON media type formatter. If I just go ahead and say continue in the application and then tell it to stop debugging because we don't need to look at that anymore, and we come back into curl, this is a JavaScript object notation representation of that string array. It's something that is easily consumed by JavaScript. And the reason it came out in JSON is because if I issue this request again with a -v to say make this verbose, then we'll see everything that went between the server and the client. And one of the things I can see is that when curl sent this request to the server, it sent it with an accept header of */*. Basically, give me anything, give me everything. So there wasn't any specific piece of information in there that the Web API could use to say, oh, they want XML or they want JSON. Well, we're not sure, so we'll just fall back to the default, which is JSON. But I can, with curl, using a $H, send off a specific header, like an accept header, and say, please give me application/JSON, and I get the JSON back that I would expect. And let me take the verbose flag off of here so we don't see everything anymore. And now I want to change this to be, please give me XML. And the Web API happily serializes that array of strings into XML. And presumably I would ask for XML if I'm in an environment where it's easy to parse the XML that comes back. And now let's try one more trick. Let's say, give me all the videos, but serialize them as image/PNG. Well, and I get back JSON. That's why this is content negotiation. I'm saying I would like an image, but since the Web API didn't have a formatter registered to take some arbitrary CLR object and make an image out of it, then I just get back with the default formatter built for me, which is the JSON. And hopefully this demonstrates to you what content negotiation can do, and the reason it is important is because now I have a web service that is very highly interoperable. If someone is programming in a JavaScript environment or a Ruby environment and they have a library or an API that makes it very easy to consume JSON, then they can walk up to this web service and send along an accept type that says, please give me JSON back. But if I'm in an environment like C#, where it might be easier to parse XML, then I can request the XML instead. Now we've seen how content negotiation plays a role with the WebAPI, and of course that influences how we return data to the client. We no longer return action results or view results from these methods, we just return objects, and the content negotiation algorithm and the formatters, they all step in and serialize the object into the media type the client wants. So that's a little different. And what's also different is how we map incoming data into parameters in an action method. I've already shown you that we can get a simple integer ID parameter into an action method, and we did that when we went to /API/videos/5 with a GET request. The 5 represented an ID, and we ended up in the action taking an ID parameter, and the value was 5. So by default, the WebAPI assumes that primitive types, like integers and strings, it assumes they'll be somewhere in the request, and it's going to go looking for them, but it's not going to look in the HTTP message body. Otherwise, it's like normal MVC model binding in the sense that the runtime will look in the query string, and it'll look in route data. That's where it found our ID parameter when we did /video/5. And it converts that value and passes it into the action, but it's not going to look in the message body. If you want to pass a primitive type in the message body, there's an attribute you need to use to tell the WebAPI to look in the body, and that is the FromBody attribute. Complex types, on the other hand, the WebAPI assumes they will be in the HTTP message body, like the body of a POST request or the body of a PUT request. POST, by the way, is generally used to update a resource. If we want to update a video, we could post to the video API controller, while PUT is generally used to create a new resource. And of course, GET is to read and delete is to destroy. I'll show you examples of all these in just a bit. But this is a significant difference from MVC, where you could bind any sort of model. WebAPI expects a single complex model in the body, and the content type of the body will decide how to serialize the message body. So those formatters, the JSON formatter, the XML formatter, the form URL encoded formatter, they will look in the HTTP message body, and when the client says, hey, I'm posting you JSON, they'll try to deserialize JSON. The JSON formatter will jump in and try to turn that into the object, the complex object that you expect in your method. Let's experiment with all this a bit. Let's use curl to fire off a couple more requests to this GET method that takes an ID parameter just to see how it behaves. And we already know that this request is going to succeed, /API/videos/5. If I issue that, we get back a response that basically says it found the value 5. It put the value in the response. And the reason that works is because of our route configuration. We told the MVC runtime when you see something like API/something/something else to treat that something else as the ID. So that particular piece of the URL gets placed in route data, and then when the MVC runtime sees that there is an action method available that needs an ID parameter, it's able to find it in route data, convert it into an integer, and pass it into us. But this also works if I don't pass it in the URL, but if I pass it in the query string. So there we get value 12. So it's looking in the query string. It's also looking in route data. And that's another area of extensibility in the MVC framework if you want it to go off and look other places too. But I'd like to turn our attention now to the post method, because eventually we're going to need to update videos, so it would be nice if we could post a video and make sure that we get the proper value back. We're going to try this with just a string first. So let me come into curl and say that the method now is post. And this particular method right now doesn't need an ID parameter, so I'm going to take that away. But I am going to pass data. So that's done with -d. And with data, typically you're providing form data. So form data usually looks like value equals Scott, and pass that along. But we got a null value back. And there's actually two reasons for that, unfortunately. The first reason is that what the Web API expects for a single primitive parameter is just equals Scott. That will get it in value, but it's not going to look into the message body. That equals Scott goes into the message body until I add that attribute from body. And now let me do a build and let me send off the request. And now you can see we pull that value out. And let's look at it one more time with the -v. And let me open up this window a little bit so that we can see that what curl did was, first of all, send off that post to /API/videos, said that the content type was application/x form encoded. That means that the form URL encoded formatter jumped into play. It looked in the message body, it pulled that value out. Now you might think that that syntax is just a little bit quirky, the fact that I had to say equals Scott and not value equals Scott. But don't worry, because when you start working with actual complex types, this works the way you would expect it. So just to do a real quick test, let's go ahead and create a video class. And let's say that this class has an ID. And let's say that every video also has a title. And now let's go to the post method, and instead of taking a primitive type, we'll take a video parameter, and I will return that video parameter just so we can see what comes out from curl, and put it here too. And I think I'll just need to make that a public class so that the C# compiler is happy, but I should be able to do a build. And now I can come down and let's do a post that says ID equals 1. And you can see we got back a JSON representation of a video with the ID property set to 1. So we got the ID through there. And I can also say n title equals MVC4. And we got that video back. So hopefully this is giving you some idea of how a Web API will work. When someone calls get or get all videos, what we're going to do is just return objects. We're going to let the content negotiation work to determine the best format for the client, the best representation of that resource, and we can also receive data the same way. A client wants to post a new video or post to update a video to our web service. We can just take a complex type as a parameter, as a video, and the formatters and the pipeline of the Web API will figure out how to take form encoded data or JSON encoded data or XML encoded data and turn that into an object for us, and then it's just up to us to do the work of saving things in the database and so forth. That's what we're going to take a look at next. Now that we know a little bit about the Web API, let's actually build out a Web API that talks to a database and saves and deletes videos from that database. In order to do this, I've gone ahead and created a video class. A video just has ID, title, and length properties. We're going to keep this very simple to start with. And I've also created a video DB. This derives from the Entity Framework's DB context. I've included a DB set of video, and this is everything we need to get started with the Entity Framework in version 5. This is the code-first approach to creating a database. And something else I can do with the Entity Framework version 5 is manage migrations of my database, schema migrations, and DDL statements. I'm going to open up the Package Manager console window. So first I'll search for that up here in Visual Studio, and then type the command enable migrations. So this is automatically part of an MVC4 application when you create a new one. It adds a reference to the Entity Framework version 5, and you have these commands available in the Package Manager console. What enable migrations will do is add a migrations folder to Solution Explorer. Inside of there is a configuration class that configures the migrations for this project. I'm going to turn on automatic migrations just to keep things as easy as possible. And this also gives me a seed method. What I can do with the seed method is every time there's a schema change or when the Entity Framework first creates a database, it will invoke this method, and I can pre-populate the database with stuff that I need in there for development. So populate lookup tables. Or in this case, maybe what I want to do is just go ahead and add a few videos into the database so that there's always some videos in the database. So the way I will do that is to walk up to the DB context derived class that we have, the video DB, and say context.videos.add or update. This first expression, lambda expression that you see here, is a way of telling the entity framework how to differentiate one video from another. So it's literally saying, look at the title property of the object that I'm trying to add and make sure that's not already in the database, because the seed method will run every time there's a migration. We can have multiple migrations, and I don't want duplicate instances of MVC4 in there. So I'm telling the entity framework, check the title. If you don't see an MVC4 record in the database, add this one, add a link record, and then context.saveChanges will just make sure everything gets flushed to the database. So with that in place and everything saved and built, I'm going to type update database. And this will go out and by default and store this database that I have and run the seed method. It's going to create it on LocalDB, which is the new version of SQL Server Express here for Visual Studio 2012. And this gives us everything we need to get started. No connection strings, no other configuration necessary. And so with that in place, I can start to think about how to actually implement get all videos. And I'm thinking that every action inside of this controller will need access to the video DB. So I'm just going to go ahead and create a private field here to hold a reference to that, include the namespace for videos.models. And then let's add a constructor here that will construct an instance of that and initialize it. So I could say db equals new video db. And I'm going to set an option here that makes life a little bit easier for me later on. I'm going to turn off proxy creation. Proxy creation with the entity framework is really there to enable change tracking and lazy loading. But when you're in an API scenario, typically what you do is grab data from the database and then immediately serialize it and send it to the client. Or you receive data from the client and you apply it to the database immediately. There's no need to do change tracking or lazy loading inside of an API controller, and it actually simplifies things a bit if I just turn off the proxy creation. And so with that in place, what get all videos would look like, what I want it to do is actually return an IEnumerable of all the videos that are in the database. And so that's as easy as saying return db.videos, and we're finished. I can do a build, and now let's just test it out in a browser before we write the web page that consumes that. So localhost /API/videos. This will send off a GET request. And what the GET request here returns is some XML that has those two videos that we seeded the database with.